Okay, so let's cover section 6.2, solving equations by using balance strategies. So the learning outcome I would like you to copy down, please, somewhere, is to model and solve problems using linear equations in various forms. And because we're using balance strategies, I went on Google and found an image of an example of using a balance strategy to solve a linear equation. Okay, so in your notes here it says to solve an equation you need to isolate the variable on one side of the equation. That's the entire point of doing algebra, to isolate the variable. Okay, that's your goal of algebra. And it says that you can use balance scales to model this. And something that's very important in algebra, need my highlighter again, everything you do to one side, you have to do to the other. Okay, and this way the scales remain balanced. So if you can kind of think of a balance scale and keeping the sides of your equation balanced, that might help. Okay, so example number 1 is the equation 3x plus 2 equals x plus 6. And they're asking you to solve it using a picture, the balance scale, and then they're asking you to solve it with an algebraic solution. So you may want to pause it at one point in order to keep up with the pictures, because you need to copy the picture solution into your notes. Okay? So starting over here, they have drawn a picture. Here's your balance. Okay, so you've got your two trays, tray 1 and tray 2, and it's sitting on a balance. And they're representing 3x by these 3 boxes here, and then they're representing plus 2 with these 2 circles. Okay, on the other side, they've got 6, 1, 2, 3, 4, 5, 6, and they've got plus an x, so they've got that square. And notice how they made these guys squares, and they made just the digits circles, okay, so you can keep track of them. So we're starting with 3x plus 2 equals 6 plus x, and on the bottom here, it says that each round circle has a mass of 1 gram. I don't know that that's terribly important, other than they each represent a 1, okay? So the picture solution looks like this. The algebraic solution, this is 3x plus 2 is the same as 6 plus x. Okay, now the next picture. Look at what they're doing. They're removing an x from both sides. Okay, you can do whatever you want as long as you remain balanced and you do it to both sides. So here they are subtracting an x. So let's go to the algebraic solution. Okay, we've got our sides going on, and we will subtract an x from both sides. Now, I'm going to write the x under the 3x. I can't subtract an x from a 2 because they're not like terms. I would have to subtract an x from 3x, and I'm going to subtract this x here from this x, okay? So x and negative x make 0. So all I have left over on my right side is 6. On my left side, I have 3x minus x is 2x, and then I have plus 2. So look at this picture down here. Well, I'll keep my pen, sorry. This picture here, I've got 2x, and I've got plus 2. 2x plus 2. On this right side, before they're removing this, I do have 1, 2, 3, 4, 5, 6. Okay, now what are they doing? They're subtracting 2 of the circles. Okay, so they are subtracting 2 from both sides, right here and right here. So let's subtract 2 from both sides. Positive 2 and negative 2 is nothing, or 0. So on the right side, I have 2x. On the left side, I have 2x. On the right side, I have 6 subtract 2, which is 4. And if you look at my picture here, I've got 2x is the same as 4. Okay, so if I was able to separate this down the middle, if 2x is 4, then x is 2. Okay, each of these stands for 2 of those. So that's with the balance scale. And let's give it a try in the check here. It says write the equation given by the picture, solve and record your steps algebraically. So I'll pause for you to try this on your own, and then you can come back and see if you got it right. Okay, so notice over here there's a 4b. That's represented by these 4 squares. So we have 4b, and then we have plus 2 is the same as 2b's. And then I have 1, 2, 3, 4, 5, 6. Okay. Now, I'm not a fan of this side by side, but I'm going to at least follow the blanks here. So I have 4b plus 2. How do I get rid of that 2? I subtract 2. Okay? If I do it to one side, I have to do it to the other. And on this, I have that 2b plus 6. Okay? So what they're doing is they're taking away these 2. If I do it to one side, I have to do it to the other. So I have 2b plus 2 minus 2, leaving me 4b. I have 2b plus 6 minus 2, so I have 2b plus 4. Okay? So I've got 4 of these b's left over. I've got 2 b's, and then I've got this 4. Next, what would you do? I'd get rid of these. I can't have b's on both sides. I'd get rid of that. But if I do it to one side, I have to do it to the other. So I would subtract 2b on both sides. So I have 4b, subtract 2b is 2b. I have 2b minus 2b is gone, is 4. So my picture on my or my left side would look like that. Okay, that's all that would be left on that tray. That's all that's left. What do I have here? 1, 2, 3, 4. 4 of these circles. And then if 2 of these b's equaled 4 circles, each of these b's would be 2 circles. So again, I'm at b equals 2. All right. Now, using algebra tiles to solve an equation. So we're instead of the balance scale, which can be a bit tedious, hopefully you don't mind algebra tiles too much. So we have negative 2n plus 5 equals 3n minus 5. I'm going to build negative 2n plus 5 I'm going to need more room. So draw these as I'm doing them. Negative 2n plus 5, and then we put a little squiggle to stand for the equals. Equals 3n minus 5. 1, 2, 3, 4, 5. Okay, so on underneath, let's get a line going. Over here on the algebraic solution, I have negative 2n plus 5 is the same as 3n minus 5. Okay. Now remember, I have to isolate. I have to make sure that I only have rectangles on one side and I've got squares on the other. Okay? Let's get rid of these two guys. Okay? How can I get rid of 2 negative squares? I can't really take them away. I don't have them over here. But what if I add 2 positives? If I add 2 positives, this goes away, doesn't it? But whatever I do to one side, I have to do to the other. So what I've done here is I've added 2n to both sides. Okay, so algebraically, I'd have, this would go away, I'd have 5 equals 5n minus 5. Or my picture, I would have 5n minus 5, I'm going to cheat and just copy. I'd have 5n minus 5 on my right side. On my left side, these guys went away. Those are gone. So all I have left is these singles. Okay. And And I'm going to continue my line on. Okay, so look, I only have rectangles on the right side. That's good. I have squares on the other side. That's good too. I want to get rid of these 5 guys, but look at if I subtract 5 negatives from here, I don't have 5 negatives over there. So I'm going to do the same thing I just did. I'm going to add 5 positives to make all those 0 pairs. That will make that go away. 2, 3, 4, 5. Okay, all of these 5 positives will get rid of those 5 negatives. If I do it to one side, I have to do it to the other. Okay, so what have I done to both sides? I added 5. Add 5, add 5. So I'm left with 5n equals 10. Or algebra tiles, I have these 5. Oops, you stay there. I want these. No, I want you all there. I still have those guys. Remember, these all added to 0. I have these 5 is the same as those. And then I need 5. I have 5 of those there. I have 10 of those there. So if you do a little bit of separating, you can probably tell that each of these would be 2. This guy would be 2. This guy would be 2. This guy would be 2. And then that last one would be 2. So in the end, I know that n is 2. All right, so look at the check. It says use algebra tiles to model and solve the equation. Record your work algebraically. So if I was to build negative c plus 5 get your line. Nope. Get your line. Equals 2c. Make sure you're drawing these pictures. I'm going to ask you to do that on your test. You need to know how to use algebra tiles. 2c minus 4. Okay, that's my first picture. Now, it'd probably be easier to get rid of this one, to get rid of these 2. So how, what have they done here? Yeah, that's what they've done as well. So in order to get rid of this negative one, add a positive, because that makes a 0 pair. If I do it to one side, I have to do it to the other. So my next picture will look like this. These are gone, so those guys remain. 2, 3, 4, 5. Okay, that's my second picture. Now what have they done up here? It says negative c plus 5 minus c. Huh. Okay. I'm going to ignore this. I didn't do it the way I'm going to do it. I'm going to ignore this, and I'm going to tell you what I did. I had negative c plus 5 makes 2c minus 4. I added a positive c to both sides. I think that's easier than what they're doing up here. I added a c to both sides. So I have negative c and positive c just leaves that 5. I have 3c minus 4. So I have 5 equals 3c minus 4. Okay, I have rectangles here. I have squares here. I want to get rid of these squares. How do I get rid of 5 negative squares? Or sorry, 4. How do I get rid of these 4 negatives? I add 4 positives to make 0 pairs, and they add to 0. Okay, if I do it to one side, I have to do it to the other. So what did I do? I added 4 to both sides. So I have 5 and 4 is 9, makes 3C. So over here, I have all 9 of these little squares. All of these add to nothing or add to 0. So I still have those. Now I've got 3 of those. So if I have 3 of these equals 9, each of them equals 3. There we go. So I can say that C equals 3. Okay, example number 3, solving equations with rational coefficients. It says solve the equation, then verify the solution. Okay, we would never do this with algebra tiles or balanced scales. This is just straight up algebra. So let me rewrite the question so that I can use it. 2a over 3 makes 6. Now remember, algebra is all about getting the variable by itself by undoing what's happened to it or by doing the opposite. Okay, so look at a. It's being multiplied by 2 and it's being divided by 3. Now, remember what I said before about this 2 is attached to the a. It's 2a. So I'm going to leave that to the end and I'm going to get rid of that 3 on the bottom. Okay, what's the opposite of dividing by 3? Multiplying by 3. So I'm going to put it on the top because I'm going to multiply 3 by 2a. Remember, if you do it to one side, do it to the other. Now, what's the point of multiplying by 3? This 3 will cancel that 3, leaving that 2a. And I have 18 on the right side. Okay, remember the whole goal is to get this a by itself by undoing what's being done to it. All right, a is being multiplied by 2, so divide by 2. Do it to one side, do it to the other. Again, we have those 2's canceling, so I'm just left with a is 9. And there's my answer. Verify the solution means plug it in and make sure it works. So 2a, which is 9, over 3 has to make 6. Okay, take this 9 and plug it in there and make sure it works. 2 times 9 is 18, and 18 times 3 is 6. So I got it. Okay, you try the check and then come back and make sure you got it. All right, so I'm not a fan of this all stuff. I'm going to get rid of it. You can just go beside if you want and ignore it. I'm going to get rid of all that. Okay, I'm going to do a fix part 2. Okay, I have x over 4 makes 5. So I'll rewrite that just so I can draw on it. So I have x over 4 makes 5. X is the variable that I want to isolate. What's happening to it? It's being divided by 4. Opposite of dividing by 4, multiplying by 4. Do it to one side, do it to the other. My 4's will cancel, leaving just x. On the right side, I have 20. That's my solution. To verify, fire it back into my equation. 20 over 4 has to make 5. Is that true? Is 20 divided by 4 5? Absolutely. Okay, second one. I have x over 4 plus 7 over 4 equals 5 over 4. Now, a little more complicated, but you can handle it. All right, left side, right side again. And what I would do here is I have x over 4 plus 7 fourths equals 5 fourths. This x is being divided by 4. Get rid of the 7 fourths first. I'm adding 7 fourths, so subtract. Oops, 7, subtract 7 fourths. Subtract 7 fourths. Do it to one side, do it to the other. On. So I have x over 4 makes 5 fourths minus 7 fourths is minus 2 fourths. Okay. I should have done that. Okay. Now, how do I get rid of dividing by 4? Dividing by 4, the opposite is multiply by 4. If I do it to one side, do it to the other. Cancel, leaving x. Cancel, leaving -2. There's my solution. So, do my check. -2/4 plus 7/4 has to make 5/4. I have common denominators, so I can just add my numerators. -2 plus 7 is indeed 5. Okay? So, get started on your practice. Make sure that you do the online quiz, and 6.2 has a skill builder, so make sure that that's been completed as well.